Hello everyone. In this video, we are going to talk about concurrency control problem and the problem and various types of problems in the concurrency control. First, we will start with the definition. When many people want to try to make modification to a database at any point of time, there should be a system of controls in place to ensure that changes made by one do not adversely affect the other. This is called concurrency control. It usually deals with interleaved execution of more than one transaction. When multiple transactions execute concurrently in an uncontrolled or unrestricted manner, then it might lead to several problems. And these are the problems that we are going to study. They are also known as concurrency problems. There are four major concurrency problems, and we will study each of them in detail. The first is the dirty read problem, second is unrepeatable read problem, then phantom read problem, and the lost update problem. Now starting with dirty read problem. Dirty read problem means reading the data written by an uncommitted transaction is called dirty read. There is always a chance that the uncommitted transaction might roll back later. Thus, uncommitted transaction might make other transactions read a value that does not even exist. This leads to inconsistency in the database and this is because of the dirty read problem. Although dirty read problems not always lead to inconsistency. It leads to inconsistency when the failed transactions roll back later, then only it will lead to inconsistency, otherwise it is not problematic. Now we will study an example of dirty read problem. There are two transactions, transaction 1 and 2, and this is the explanation of the example. Here, T1 reads the value of A. T1 reads the value of A and then T1 updates the value of A in the buffer. So T1 reads and updates the value of A. Then T2 reads the updated value of A and T2 writes the updated value of A. But during that time, T1 has not committed its transaction and it later leads to failure, but T2 has committed its transaction beforehand. But the T1 transactions rolls back later. T2 reads the dirty value of A written by uncommitted transaction T1. Then T1 fails in later stages and rollbacks later. Thus, value of T2 reads now stands to be incorrect. Therefore, database becomes inefficient and inconsistent. Next problem is unrepeatable read problem. This problem occurs when a transaction gets to read unrepeated, that is, different values of the same variables in its different read operations, even when it has not updated its value. For example, there are two transactions T1 and T2. T1 reads the value of A, then T2 reads the value of A. Then T1 writes the value. So T1 reads the value of A, T2 reads it, T1 updates the value and T2 again reads the value. But in this example, the updated value is read by T2, which is not similar to the ones read before, and this leads to inconsistency as T2 wonders how the value of X got changed because according to it, it is running in isolation. Next, the major part of this video should be phantom read problem. This problem occurs when a transaction reads some variable from the buffer, and when it reads the same variable later, it finds that the variable does not exist. Example again, there are two transactions T1 and T2, and this is explanation. T1 reads the value of X, then T2 reads the value of X, and then T1 deletes X. Later on, when T2 tries reading value of X, but it does not find it. In this example, T2 finds that there does not exist any variable X when it tries reading again. T2 wonders who deleted the variable X because according to it, again, it is running in isolation. All transactions, according to ACID properties, are running isolatedly and they are not connected to each other. They are running isolatedly and they are independent of each other. So this problem is called phantom read problem. This is the example of it. Now the last problem is lost update problem. This problem occurs when multiple transactions execute concurrently and updates from one or more transactions get lost. There are two transactions T1 and T2. T1 reads the value of A and T1 writes the value of A. T2 does blind write on value of A T2 commits it. But when T1 commits, it writes 825 in the database. In this example, T1 writes overwritten value of x. T1 writes the overwritten value of x in the database, thus updates from T1 get lost. This problem occurs whenever there is a write-write conflict. In write-write conflict, there are two writes, one by each transaction on the same data item without any read in the middle. So these are the four concurrency problems that we studied. These are again dirty read problem, unrepeated read problem, phantom read problem, and lost update problem. These problems are the four problems that makes the database inconsistent. To avoid inconsistency and ensure consistency in database, it is very important to prevent the occurrence of these problems. The concurrency control protocols helps to prevent the occurrence of above problems and maintain the consistency of database. So that's all for this video. Hope it helps. Thank you.